The expression formed by adding the terms of a geometric sequence is called a geometric series. The sum of the first n terms of a geometric series is notated by S sub n, just like it was for our arithmetic series, and can be found using the following formula. So the sum of the first n terms of a geometric series with your common ratio r, when r is not equal to 1, is given by S sub n equal to your first term times 1 minus r to the n power over 1 minus r. R again is your common ratio, n is your first number of terms that you're given in your series. So let's look at example 4 and put this geometric series rule into place. So in example 4, they want us to find the sum of the first 10 terms of the geometric series, 10 terms. And we're clearly only given 4. So we can continue this pattern out 6 more times, or we can use our formula given to us on the previous page to find the sum of this series. So, since we're looking for 10 terms, we know that n is going to be 10. From our sequence here, we know that we're trying to find the series. So the series obviously has us adding all of these terms up, and they continue on 6 more times. But I'm not going to continue the pattern. I'm just going to use the rule or the formula here. I know that my first term in this series is 5. My common ratio, if I look at it, 10 over 5 is 2, 20 over 10 is 2, 40 over 20 is 2. So I know it's geometric because I have a common ratio, which is 2. Therefore, if I use my formula from the previous example or the previous page, S sub 10, so I'm plugging in 10 now for my n value. So my series, my sum of my series for my 10 up to 10 terms is equal to my first term 5 times 1 minus my common ratio, which is 2, to the nth power, which is 10, all over 1 minus 2. Well, if I take this value, 5 times, well, if I take 2 to the 10th power, I get 1024. So 1 minus 1024 gives me negative 1023. All over 1 minus 2 is negative 1. Double negatives cancel out. Anything over 1 cancels out. So this becomes 5 times 1023, which if we plug that into our calculator, we get 5,115 as the sum. Again, you can carry this out, you can follow this and multiply this by 2 and get your 10 values for the series together and then add them all up. But again, if you're wanting to find the first 100 terms, that's obviously going to be long and tedious. So the formulas come into place because they make that operation a lot easier to be able to find the sum of those series. At this point, we're done with all the examples for lesson 3. I want you to work on Now You Try's numbers 8 and 9, and then your homework that'll be due the next time we meet is going to be checkpoints numbers 1 through 6. So again, you're working on problems 1 through 9 in the Now You Tries, and then the checkpoints numbers 1 through 6. So you have another 15 problems to do for the next time that we meet, and we'll check those answers together at our next class. Email me if you have questions. Otherwise, I will see you then.